So new unit, new beginning. Let's get into this. So now we're going to talk more about the actual geometry and how it's applied to things like lines, angles, and eventually triangles, which is what the unit activity is going to be talking about. So if any of you guys are struggling with that unit activity, try to take a look at it and try to understand what it's asking you ahead of time. Because, like, again, if you save it for the last minute, I've been entering the grade slowly but surely, but if you save it for the last minute, I've noticed a lot of you are taking time on it because it does take a while. So let's kind of get into this one. So we're going to go into lines, angles, proofs tutorial. All right, and this is a long one. So forgive me if I have to rush through it again. Unfortunately, with geometry, this as we get deeper into it, it's going to build on itself a lot. And if you guys do need help with the tutorials, as always, just make an appointment. A few of you have already, and that's great. Use me as a resource, guys. If you're struggling with stuff, let me know. That way we can talk about it. So in this lesson, our objective is to write mathematical proofs, apply knowledge to simple geometry relationships. So the idea of proofs is kind of like writing an essay. So I don't know if any of you guys have taken Josh when it comes to English, but when you write an essay, you have to like prove your point across. So essay writing is a skill that takes time to develop. You have to state your fact and defend your fact. So you state something, then you have to defend it. Proofs in math are kind of the same way. You state a statement and you state why that statement is true, your evidence, your supporting evidence. So in this case, they're talking about law and stuff where people have to state something and then defend it. And that's what we're doing here. In proving conjecture, we're trying to prove a theorem, or we're trying to prove a fact by using theorems. So, for example, this is our given statement. So that's what we're doing. And when we do this next step, we're saying this is our next statement. Why are we allowed to do that? Because of the distributive property. Okay, then we're combining our 2x and our 3x to become 5x. Why are we allowed to do that? Because of addition. Addition lets us do that. And then we want to move everything to both sides. So how do we move the 8 to both sides? We have to add 8. Why are we allowed to do that? The addition property of equality. They get really specific with these, but that's basically the idea. Why are we allowed to do that? Why are we allowed to add to both sides? Because if we add something to both sides, we're allowed. If we add something to one side, we have to add it to the other side. That's what it means by property of equality. We want it to be equal, so we have to do it to both sides. Why do we have to divide 5 by both sides? Because that's what keeps it equal. Division property of equality. Sorry. So that's how we write proofs. So in proofs, this is a good table for you guys to have written down somewhere. Transitive reflective property, that's just saying if A is always equal to itself. It doesn't make too much sense right now, but once we get into like triangles, let me draw some shapes right now. Once we get into like shapes, it is kind of necessary to prove it. Oops, not Calendly. Okay, cool. Well, they updated it. That's cool. All right. So let's say, for example, we have a triangle here, and we have a line down the middle, and we're trying to say that this triangle on the left is equal to this triangle on the right. And we're trying to prove it using different theorems. Like we're saying like, oh, this angle or this side is congruent to this side, and this side is congruent to this side. It's like, how do we prove that they're equal? It's like, well, we can say that side AB is equal to CB, and then we can say that AD is equal to DC, but how can we really prove that BD is equal also? It's like, well, we have to use what's called the reflexive property. It's kind of those properties that's like, obviously it's equal to itself, but remember in geometry, we have to keep everything the same. So if we're saying that this triangle is called ADB, and we're trying to say that it's congruent to C is the side that we're talking about here that matches up with A. We have to keep it in order. So we're saying C, D is this right angle that we're keeping here. So it goes next, and then B. So we're saying that A has to match up with C, D match. So it seems kind of obvious that BD is the same, but we have to prove it step by step. And honestly, in high school, geometry doesn't get too into why we have to do it, but it is one step there that lets you kind of solve it because we're going to be using theorems like side, side, side. If all the sides are equal, then the triangles are equal. But in order to use this theorem, you have to prove that all the sides are equal. Well, how are we going to prove that one side in the middle is equal? You have to use the reflective property. Like I said, it's redundant, but it's necessary to use this theorem. Um, Sometimes they're going to be separate triangles, and it makes more sense in that case. But when they're the same, it's like, well, how do we prove that middle one? You have to use this theorem. So that's just an idea of how we're going to be using this. Saying it backwards, that's more for writing. A transitive property. This is actually really useful when doing proofs because if we're saying A is equal to B and B is equal to C, then you can just skip B altogether and just go, oh, A is equal to C. Again, this is something that might be useful to have. If you don't have these like memorized, sometimes I honestly have to Google it. Like, well, what are these properties again? Because you do need to write them down on your proof somewhere. All right. So, for example, this is saying we are given the fact that AB is equal to BC. AB is CD. AB is equal to CD. And that's why they mark it down with that one line. This little line just means that it's equal. We're trying to prove that AC is equal to, so A all the way to C is equal to C all the way to E. So they're going to use these little facts right here. Again, I know a lot of this seems very obvious, but once you start getting into the like harder proofs, it becomes very useful. So they're building it up slowly right now. This idea that, okay, these are equal. So if we add AB, so if we're adding this side and this side together, we can just use substitution rules here to prove that this and this is the same thing as this to this. So two-column proofs. Two-column proofs are useful because instead of having to write everything down, so this is a two-column proof. You're doing your statement and you're doing your reasoning right here. It's kind of like a simplistic way of writing an essay as opposed to writing this long essay on like why everything is equal. It's just like, just write down your facts. Write down why these are true. So now we're going to go into a question. So this is saying, so let's use GeoGebra to kind of prove this. Linear pairs and supplementary angles. Oh, so we kind of just skipped over. That's weird that we kind of skipped over that, but I guess we'll get into it a little slower. This is just talking about the idea of supplementary angles. Supplementary angles are always equal. The idea here is we're measuring this right here, this idea, these two angles. And if we were to add these up, let me pull out a calculator here. If we were to add these two up, 101.9 plus 78.1, we're getting 180. And this is just a demonstration that supplementary angles are always going to be equal to 180 no matter what. A line is also equal to 180. I believe we covered that earlier. A line has 180 degrees. So this is saying these angles represent a linear pair. Linear pairs are always supplementary, meaning that a straight line does equal 180. Then move the point. What happens to the sum of AB? The sum is always 180. And if you want to get fancy, you can do 180 and you can put the little degree symbol. So the sum is always 180. If I moved it again to somewhere else, if I added it up, 5.1 plus 125.9, again, 180. That's all they're saying. The sum is always 180. What can you say about these two angles based on the sum of their angles? Since the sum is always 180 degrees. Fortunately, I have to use this to kind of use my little angle symbol. Angle ADB and angle EDC are supplementary angles. How are they related? Well, that's kind of answered in the question. How are these angles related? They're supplementary angles. What can we say about them? They're supplementary angles. How are they related? They're supplementary angles. There's no need to say the sentence over again. Based on your observation, what can you say? Oh, okay. Oh, that's right. That's what I wanted to say. These angles are a linear pair. Sometimes you can kind of see what Edmentum wants you to learn based on the next question that they ask. So from here, based on your observations, what can you say about the relationship between linear pair? Linear pair angles are supplementary. So that's what they wanted us to learn from it. They wanted us to say that if we have a straight line, so if we have a straight line, that straight line is always equal to 180 degrees. So that's what it wanted us to learn from that. Some of you may have already known this before. If you took Unit 1 in the packets, I think it covers it in Unit 1. So that's why I was assuming we already covered it here. I get the packets and Admenta mixed up sometimes. I'm sorry about that. But this is letting us know that a straight line has 180 degrees. For self-evaluation, in this case, I would give myself a 5. It's like, well, I already knew that they equaled 180 degrees. So this exercise was simple. It was really simple. All you have to do is just add up the angles, right? So this is just telling us a linear pair theorem. So this is a theorem we can always use. So when we're trying to prove something, a fact, we can always count on the fact. It's like, well, if I know this is 30, then for a fact, I know that this has to be 150. Why do we know that? Well, because of the linear pair theorem. A line has 180 degrees. Um, I I studied it before as the definition of a line. A line has to have 180 degrees, but they're starting to get fancy and start naming stuff like linear pair theorem. Either way is fine as long as I kind of get the idea of what you're trying to say. But in the book, I always say the book, in Admentum, they're going to keep referring to it as the linear pair theorem. So these two are a linear pair. How do we know these two angles are a linear pair? If you ever see it on a picture, that they make a thing, it's given. So if you can visibly see it, or they tell you straight off the back, it's a given fact. How do we know? They told us. They either told us by us looking at the picture, or they explicitly said it. So either way, that's how we know it's a given fact. All right. So the next fact, they're saying that AD is a or DA, this line right here, and DC is a straight line. How do we know that? The definition of a linear pair. There are two angles right next to each other that make a line. That's a linear pair. Our next one is they equal 180. How do we know that they equal 180? That's the definition of a straight angle. I like to call it the definition of a line. I don't know why they always call it a straight angle. To me, that's kind of weird. I'm like, that's a line. The only reason I guess you can call it a straight angle is if it has a starting point and an ending point. But even then, you can say the definition of a line segment. But since this line goes on forever, I guess they like, I don't know. Some things are weird. I like using the word definition of a line. But in this case, you can use the definition of a straight angle. Why is it equal to 180? Well, because a line has 180 degrees. All right. So then we're going to say that these two add up to each other. So how come we can say that that plus that equals each other? It's just angle addition. If you add the angles together, that's how you make it in the bigger angle. All right, and they equal to 180. Why? We're substituting. We're just substituting this fact and this fact together. So we're taking this, substituting to there, and that's how we can get here. So I know proofs are like they seem kind of obvious, but when you're making these up on your own, it does get a little more challenging. All right, so, and then if you guys aren't understanding anything, feel free to mention it in the chat. And while I'm looking at the chat right now, I like seeing your answers, guys. Make sure if you came in late and you see people answering weird questions. I know sometimes you can't see the older chat. The attendance questions are: what qualities do you look for in a friend? Is the first question. Second question is: what's your perfect Sunday? And third question is: if you could excel at a competitive sport, which would it be? Just either tell me your number, or I'll be able to honestly answer it. Tell which question you're answering before. It's just for me to get to know you guys as well as take attendance a lot more efficiently. All right, so moving on here. I'm sorry to all you people watching this on YouTube after the fact. You're like, what about these attendance questions? But feel free to comment on the YouTube video. All right, so next we'll use a 2-column proof to prove another theorem. So we're going to try to prove that this angle and this angle are congruent to these angles. So they're trying to get us to prove that this and this are supplementary. So we're trying to prove that they're supplementary. So let's see everything here. So I'm just going to click show all. So here what they're saying is we're given the fact. So these angles are supplementary to the common angle this. So they're saying that these two angles, ABD, all right, so this is talking about this angle, and this is talking about this angle, and they're going to be supplementary to this angle. Okay. So first of all, we're saying that this and this equal 180. That's fine. So then they're saying that, let me use my colors. This, I'm using my colors because it's faster than me kind of like saying everything. Those are congruent. So because those are all equal to 180, using this supplementary angle theorem or definition of supplementary angles, we can just use a transitive property. Remember that transitive property was the idea that if A equals B and C equals B, then we can say that A equals C. That's the transitive property. So we're using that transitive property that we learned from that slide. Again, you guys should have that somewhere. Take a picture of it, like print it out, write it down somewhere, screenshot it, whatever helps you guys remember it, or just have it available. I always have to end up Googling it. And then because of that, we can say that these two angles are congruent. So, or these two angles equal each other. The measurement of these angles equal each other. That's one important thing. I don't know if I've gone over it too much, but if we're talking about this, we're talking about the measurement. Measurement is a number. We're saying two numbers equal each other. When we're saying things are congruent, we're not saying that this angle is equal to this angle. We're saying the measurements are equal. The difference between that is if we say the angles are equal, we're saying it's literally the same angle. I know it's picky. I'm not the one that makes up the rules. That's just how geometry is. If we say that the angles are equal, we're saying it's the same thing. If we say they're congruent, we're saying that they have these angles have the same value, have the same, I guess properties would be better. We're not saying that they're the same thing. We're saying they have the same properties. That would be kind of like if two students had the same scores on the test. We wouldn't say those two students are the same person. We would say that those two students have the same skill when it comes to that subject. So that's the difference between saying the measurements are equal versus the angles themselves are equal. If two people have the same score, think of this measurement as the score. We're not saying that those two people are the same people. We're saying that they just have the same score. I know I'm going way too into that. I just want you guys to know the correct notation for it. Again, I'm not the biggest supporter of that, but it does make it easier when you're trying to read a proof. In the figure here and here, we're gonna learn about vertical angles. So we're gonna learn AEC. So AEC. So AEC is this one, and we're gonna say bed. BED is this one. So this is vertical angles. They're opposite of, well, they're across from each other, is I guess the best way to say it. They're two lines. So two lines are crossing each other, and the angles that are across from each other, those are known as vertical angles. So let's get into vertical angles. So we're trying to prove that these vertical angles are congruent. So first, it's giving us this fact. ABC, those are vertical angles. It's given. So what's our given? What did they tell us right away? Well, they said that those are vertical angles. So we're going to look for where it said that they're vertical angles. Right here. These two are vertical angles. Definition of vertical angles. So we're trying to figure out what the definition of vertical angles are. So vertical angles were created by these two lines. So they're created by these two intersecting lines. How were these made? They were made by that. Well, how do we know that these two were created by that? Well, it's the definition of vertical angles. Vertical angles are made by two intersecting lines. That's how we know that they were created. So now we're finding something that has the linear pair, definition of linear pair. So we're trying to say something that equals 180. So we're trying to say these two are linear pairs. How do we know they're linear pairs? Again, it feels very redundant. It's the definition of linear pairs. So I really should have taken a picture of that. But it's basically saying that this angle, and so hold on. Let me see if I can recreate this. A, E, D, and this is B. Oops, B, and this is C. Okay, there we go. So it's saying here that this red angle and this yellow angle are a straight line. How do we know that they're a straight line? It's the definition. We already know that DB is a straight line. So by the definition of linear pair, they're a straight line. It's also telling us about, let me change colors here. Ooh, I don't have good colors. This green angle and this blue angle. I should have made the lines black. Those are a linear pair. Why? Because they're a linear pair. Okay, then we're also saying that these two angles up top are supplementary. Why? Because the linear pair theorem. Why are they equal to 180? Well, this theorem that we proved earlier in the class. So then we could say that these two angles are congruent. This angle, this red angle, and this blue angle are congruent. So from here, now we can just say that vertical angles are always congruent. These two are vertical angles, and they're congruent. So by all of this logic, we can say vertical angles are congruent. Is this making sense, guys? How we can use proofs? Yes, no, maybe? Let me know in the chat. A little bit. Is there anything you guys want me to go over? Like something that's not making sense? I know I'm going through it a little fast. Okay. Some of that, to be honest, is going to go away with experience and exposure. So make sure you're really understanding these theorems and they'll start kind of making more sense. It's very weird at first. Um, I remember when I took geometry in high school, everyone hated proofs. Unfortunately, it's a big part of geometry, though. So we do kind of have to go over it, and I'm going to try to help you guys kind of understand it. It's really hard. There's flow diagram proofs also. I'm not a fan of this. The reason being is I don't really see the point because for example, in this case, they're just proving two facts at the same time when they're doing their two column proofs. They're like, oh, both of these have the same reason. So when they do this split off, it to me it's kind of weird, but it's the same idea. You give a statement, you give your reason in the bottom. Statement, reason. Those two statements will lead up to another statement that'll come. And I'm going to try to do the proofs a lot during the actual tutorial, so hopefully that'll help you guys kind of get accustomed to it. You guys are lucky because you're starting from unit 1. There's a lot of students that are using Edmentum second semester and they have to do the proofs and it's really hard because they didn't get this slow ease into it. So write down the lengths of A, B, C. So we're going to figure out these lengths. Wait till this shows up. And again, make sure you guys are saving your links and putting it in here. You can also put a picture in too. You would just insert a picture. There's several ways to do that. Is this stuff just, oh, I can't do it because I don't have my Adobe on. I need to fix that. So you can always save a picture. I use this little snipping tool. I don't know if Chrome has a snipping tool, or there's also little plugins you can use that can take a screenshot of whatever you're looking at on the page. If you ever need to like look it up, you guys can do plugins Google Chrome. If you're using a Chromebook, you're using Google Chrome for your browser, you can go here and look for like a screenshot plugin. Extensions. screenshot, or you can use print screen. There's a bunch of different ways to do it. If you guys need help figuring out how to take screenshots, let me know. So for this one, we're literally just going to write down the information that they're giving us. They're like, write down these lengths. So for AB, let me write measure of AB. How long is AB? How long is the line segment? Technically, I think we're supposed to do the little line up top like this. If you guys leave it as measurement of AB, that's fine, because if you don't put the line up top, technically you're saying the distance between A, B. You're not talking about the measurement of the length. I know that's a little weird. It's very picky on how they talk about it, but to me, I'm not going to mark you guys down for this. I do want you guys to write down the little angle symbol when you're talking about angles. It's just helpful for me. But when it comes to like a line segment, I'm not too worried about it, because line segments and distance are usually used hand in hand. So AB 3.17, and then measurement of, you can move this around. I usually just move this around when I'm trying to do this. Put this little line segment here, CD, and C to D is 3.7. 3.17. Again, guys, I want to cover as much as I can, so I'm not going to go, oops, and then I messed up here anyway. I'm not going to fill all of these in, but you get the idea. They're doing it for all three of these. And I really wish I could do all of them for you guys, but we only have class for an hour, and I want to get through as much as possible. So what can we say about these? So I would say something like AB is congruent to CD. And then I would also say something like, oh, A to C is congruent from B to D. So we're going to say that. So we're going to say like something like A, B, and C, D are congruent. Another thing we could say is something like the measurement of AB is equal to the measurement of CD. This would kind of be like how we would start a proof. The measurement is equal to that. Why? Why? They're given. They gave us these angles. Given. Sorry, I was going to do a capital G and then just kind of messed up there. All right, they're given. So these two are congruent. Why do we know that? Definition of congruency. Why are we doing that? Why are they congruent? Because the measurements are the same. The measurements are the same, and by definition of congruency, if the properties are the same, they're congruent. So, and then we're saying AC is that, and now it's going to tell us, now select a point A, B, D, C, and measure these angles. So basically what it's saying is grab this, drag this, and move it. And they use the property on GeoGebra that makes CD always equal to AB. So that's why this keeps happening. But if we look at it, they're always moving. They're always congruent. I always think these exercises are a little pointless because it's a special condition that makes it equal. So it's kind of weird to me that they're like, oh, do it. What do you see changes? Does the relationship? It does not change. So does this relationship change? No, it doesn't. they're always congruent. No, they are so no, they are always congruent. All right. In general, what can you conclude about AC and BC and the lengths are equal? In general, what can you conclude about the lengths, blah, 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 are equal? So what can you conclude about this? Um, one thing I could conclude that I notice here is if I'm saying that, let me use colors here to kind of illustrate it. If I'm saying that this and this are equal, and I'm also saying that this to this is equal, then I could say something like BC is equal, right? Because let me kind of write it down as a proof. So if I wrote this down as a proof, I would say something like AB is equal to CD. Why? It's given. And if I wrote this down as a proof, I would say like AC is equal to, what was it? DB. Why? It's given. I could say, oh, I'm sorry, guys. I could say something like, oh, A B plus BC is equal to AC. Why? Definition of line segment. Again, if you're writing this proof down by yourself, I'm not too picky on the reasons as long as I kind of understand what you're trying to say. It's like, oh, he's trying to say that this line right here plus this is equal to that line segment. I get it. I get what he's saying. And I can also say something like DC plus CB equals, what was it? BD. BD. Why? Same reason. Definition of a line segment. So from here, I can say that this is equal to this. I'm not going to write all of this down because I realize this is taking up a lot of time, guys. I'm sorry about that. But I can say that those two are equal. Well, because I know that AB and CD are equal, I can just cross these out, subtract them. So subtraction property of inequality, I'm subtracting these out after I substitute it. So I'm doing a lot of stuff here. I'm substituting first, and then I'm crossing them out. So substitution, then subtraction property of equality, and then from there I'm saying like, oh, cool, then CB is equal to CB. So that's just kind of like a mild introduction to this. I know, like I said, it's kind of repetitive, but I kind of saw that there and I just wanted to say. So, what can you conclude about this? Well, they're equal to each other, obviously, because of reflexive property, but you can just use stuff like that. I just saw this opportunity to teach you guys that. Don't worry about it. I was just kind of thinking about proofs at the time and how I can relate it more to you. Hopefully, that didn't confuse you more. What can you conclude about lengths if those are congruent? So if those are congruent, then what did I say here? Again, just write whatever you guys can come up with. I saw that, but not that big of a deal. One thing that you can come up with that's a lot easier than all that proof I did. If you subtract these, you can say that BC is equal to 8.2222 minus 7 minus 8. You can come up with the exact number, or you can just say something like, what is it? Which one's the long one? Sorry. It's easier when these two are on the same page. You could say something like BC, the measurement of BC is equal to AC minus AB, or, which is equal to, actually. Sorry, guys. I know I keep flopping back and forth, which is also equal to BD minus CD. Does this make sense? A little bit, kind of, sort of. Did I confuse you guys more? Okay. So that's all I'm saying here is, how can we figure this out? Oh, you just take the long one minus the short one. And by the way, that's also equal to this. That's what I can conclude from it. Self-evaluation. Write whatever you think. I expect a lot of you guys are going to be like, proofs are hard. And they are. It's really weird. Even though that one had nothing to do with proofs, I just went off on a random tangent. And hopefully this will load. I don't know what that's about. That's new. All right. So here they're probably going to go over what I just said, to be honest. They're saying that those are equal. Cool. So given, we know that those are equal. We also know that those segments are equal by the definition. They're literally doing the proof I just did. That's equal to itself. So then they're going to use addition property to say that. Then they're going to do this, the line segments. You can just add the line segments together. They're literally going over the proof I did. So you guys can review this for a better understanding. They're probably explaining it a lot better than I am. So it's just saying that AC is equal to that. So they're just proving it a different way. I kind of went to the conclusion that BC equals B. This was supposed to be a fact I was supposed to use in my proof. I kind of did it backwards and assumed this. I used this instead of this. So just, I messed up and I put 3 and 7 kind of backwards. But this is the idea of proofs. You're stating your fact and your reasoning. I didn't realize they hadn't told us this fact yet. I just went off of what it was saying. This one, I guess, is a little different because they didn't tell you that fact. All right. So now they're going to make us do this little flow proof. So what's given? Well, what's given is usually what's given, for lack of a better term. So we're looking at this picture right here. So what's given? Well, we're given the fact that AD is equal to EC. So AD is equal to DC. So just to kind of do a little illustration, they're saying this line is equal to that line. And these little hash marks are kind of like a way to let us know that they're equal. So what's given is, where is it? Oh, they also told us that this point B is the midpoint of this whole line. So that's given. All right. So if this is the midpoint, then we're saying that this line is congruent to this line. Why? Because the definition of a midpoint is right in the middle. It splits it in half. So we're saying that AB is equal to BC. Why? Definition of a midpoint. So Definition of congruent segment. So I'm trying to figure out what they mean by this. AD congruent to that. I feel like we're missing the other given fact. This part right here. All right. So definition of congruent segments. Oh, really? Oh, wait, no, we already did that one. So now they're just saying this. What? I really hate this. So again, this is why I don't get picky about the line segment, guys. What's happening here is they're just saying that the distances are equal. So A to B is the same distance as from here to here. Again, these you can pretty much use interchangeably. I honestly don't. I think these are both the same fact. It's saying the same thing. It's just how things are written. Um, so let's kind of look into this. This is saying that AD plus DB is equal to AB. Huh. Well, that's just how we make line segments, right? So if this is just how we make line segments, it's segment addition. We're just adding those line segments together. Cool. Now, if we look here, this is kind of weird. It's saying that these are equal. So remember, if this is equal to that and then that's equal to that, we're kind of substituting some facts in. We're substituting AB is equal to that. We're saying we're just substituting instead of writing AB, we're going to write AD. And instead of writing BC, we're going to write this BE plus EC. Sorry, I know it's hard for you audio learners because it's a lot of, oops, wrong one. I meant to do this one. Sorry. Wait, what? Oh, derp. That's subtraction property. I meant to do substitution. I said substitution like a million times and I clicked subtraction. Um, so I'm sorry for you auditory learners. This is geometry is a very visually based subject. I struggled with geometry. I was good at a lot of math, but I really struggled with geometry because it's very visually based. So you visual learners are probably going to understand this a lot better. So from here, we're essentially saying these are equal. Why are we saying those are equal? It's like, well, think about it. If we cancel out this, oh, I forgot. We're forgetting this part right here. This part where it says dB is equal to BE. So dB, where's that statement? Oh, here it is. AD is equal to EC. That's given. So this flow proof is kind of putting your two givens and they're kind of doing it together. So I'm not the biggest fan of flow proofs. This looks like a huge mess to me. Some of you guys might kind of see it like, oh, okay. Okay, so this is a fact we can just tell by the picture and go through it. This to me is a huge mess. I like two column proofs myself. So what they're doing here is now if we cancel out this AD and this BE, so let me visually show you guys that. So if I cross this out, AD and BE, I get this fact here. So when I'm canceling like that, all I'm doing is I'm subtracting both sides to keep it equal. So this is basically proofs in a nutshell. I've seen some students just kind of drag until they get it right. Try to understand this because if you just try to just drag it until you get it right, it's really going to hinder your learning. I know it takes a while to do these, but I do kind of want you to go through them. Paragraph proofs. This is literally just typing it out. I'm sorry, guys. I realize that I'm running short on time. Would it be okay with you guys if I finish the last like 11 slides as a separate video, kind of like I did for that other one? All right, cool. Yeah, sorry about that. I I really get into the lessons, but yeah, I'll do the last 11 slides in one video, and I'll try to do it in exactly one video, not like I did last time where I had to make it 3 videos. If you guys need help learning this, because proofs are a little bit challenging, let schedule an appointment with me. All right. Oh, and for those of you that came in late, the questions were: what qualities do you look for in a friend? What is your perfect Sunday? And if you could excel at one sport, what would it be? If you guys already answered those questions, you're free to go. If you haven't answered them yet, answer that. That way you get credit for being here. All right. So other than that, I'll see you guys Thursday. No problem, man. Later. I'll post the questions again so you guys can read them in the chat.